All right. So our next case that we'll be going through is I'll be handing it over to Juliana Mejia Franco to talk about her work with an industrial client. So this is at a industrial site. They'll be looking at some
Yeah.
of those more challenging waste streams than your typical municipal influent that we deal with in a lot of cases. So Juliana, take it away.
Hi, Alex. Thanks a lot. I'm really glad to be here to share some of the details of this success story. MitsubishiChem manages multiple industrial wastewater treatment plants in Japan, mainly to treat the processed water from their diverse portfolio of products. But in this case, it was the R&D team who contacted us because they were looking for different alternatives to monitor organic loading at both the influent and the effluent of their biological systems. And more specifically, because they wanted to develop some optimization strategies to save energy and also reduce the occurrence of imbalance events. And by imbalance events, I mean overloading events and also some toxicity events from coming from their own influent. In this facility, which is rather small, it's 360 meters cube per day. They treat water mainly from semiconductors production, but also from some other miscellaneous chemical products. It consists on membrane biological reactor or MBR that is designed to remove organic matter and also nitrogen. Well, why Sentry? That is the question that we would want to share with you because it's the most important part here. Despite having a really heavily instrumented treatment plant, this treatment plant in particular had TOC sensors, nitrogen, well, ammonia, nitrate, nitrite sensors, flow, like all kinds of sensors you can imagine. But they were really interested in knowing which were the benefits of having biological sensors. They knew that they could bring a better picture of water treatability and also systems health, the biomass systems health. To address these two, let's say, unknowns for them, they wanted to install one sentry system. And by system, I mean one panel and two sensors. One sensor in the influent to address the first, let's say, unknown, to have a better picture of the water treatability at this plant. And the second sensor in the return sludge tank, or kind of a selector there, to have a better picture of the biomass health. So they wanted to compare both TOC values as a, let's say, a metric of organic matter in their influent, and also address any concerns for pH variability and see if any of that variability could affect the nitrogen removal. So initial findings. Well, remember that the first objective of this deployment was mainly to assess how Sentry could be useful to monitor organic loading. And why organic loading? Well, because it's organic loading that key parameter that dictates how much airflow you need downstream. And it's, again, key to maintain a really healthy level of dissolved oxygen in the aeration system, right? Instead of just comparing our signal with organic matter metrics, such as in this case TOC, we wanted also to have a view of how was this relationship with DO, because DO is the real indicator of how much carbon is being assimilated in the system. So you'll see in this graph, the top graph, that's the relationship with TOC. You'll see that it is a really good match, especially at the end of this period, but it's not perfect. We were expecting this. Why? Because the Sentry signal is not only affected or influenced by organic matter concentration in the water, but by also some environmental factors such as temperature and some other variables such as pH and some differential flows there. So we wanted to see what was the actual relationship with DO or dissolved oxygen. And that's exactly what we were really expecting, to have a very clear inverse correlation with DO. This correlation was really, really good and good enough for them to be able to conclude that Sentry signal is a very good predictor of how much dissolved oxygen needs downstream the influent. So, well, many operators, this is very valuable for any treatment plant. So in their own words, the main conclusion here was that TOC and aeration tank dissolved oxygen can be estimated from Sentry sensor signal and from sludge temperature. So this last bit including temperature in all this equation and in all this, let's say, relationship was key for this plant. Because remember, I mean, biological sensors are also influenced by some environmental factors, and well, they found this relationship to be very clear. I must say that if it wasn't for the active participation from the operational team and from the R&D team, well, this conclusion wasn't been able to be drawn there. And also the new maintenance approaches, a new plan to maintain the sensor on a regular basis wouldn't have been able to be developed. They found that there were some, let's say, challenges with influent pH, with temperature variation, with some membrane cleaning products, let's say return flows, interfering with the system, not only our signal, but also their own system. So with their input, we were able to define a clearer way to maintain the system and have a really good quality signal all the time. So really kudos for their participation here. So next steps, they were really happy with these conclusions. The main idea here is to develop optimization strategies. So with that conclusion drawn there in this small plant, they moved now, they transferred all this equipment to a new treatment plant in another prefecture in Japan to start developing aeration optimization strategies and to start, yes, implementing all these new plans in other plants. Well, really good success at this plan. I'm really happy to having been able to participate in all that.
Fantastic. Thank you so much, Juliana. I mean, I'm sure everyone on the call knows that industrial effluent is definitely a big question mark. It's very difficult to get a handle on the variability, the extreme conditions that you're trying to use biology to treat. So having this insight and these clear paths forward with heavy industry is something that's very, very exciting for having better treatment at those facilities. So we're pretty thrilled to hear about that.